starting with 8/6, and now we're going to look at how do I condense and expand logarithms. So we just went over the generalizations of those. Those generalizations are going to help you expand and condense logarithms. First, let's remember how to evaluate. So, evaluations. Same process. Well, based off of our first examples, we could just have done 3 to something and we would have gotten an answer and subtracted them. But can 54 or 6 become a base of 3? No. So what if we use our properties? Subtraction property, or the quotient rule, states that if we have the same base, I can rewrite this as the first number divided by the second number. Okay, so that's helpful. Well, what is 54 divided by 6? Well, it's 9. Huh. Can I now transfer 9 to have an base of 3? Yes. So this is the same thing as saying log base 3 of 3 squared. So our answer to number 1 is 2. Well, that was helpful. So we're using our properties now to manipulate the evaluations. That way we can get to an answer. Okay. Well, number 2, we have log base 7, 49 to the third. Whew, that's a pain. But we could remember our power rule that says I can manipulate that 3 to come out and be in front. So this becomes 3 times log base 7 of 49. 49 is a lot easier to deal with than 49 to the third. So I can now manipulate 49 to be 3 times log base 7. 49 is the same thing as 7 squared. Well, I got these to be the same. So this should be 3 times 2. So the answer to number 2 is 6. All right. We're starting to see what's happening. I would like you to take a moment, pause your video, see if you can figure out 3 and 4. Okay? I will continue though. So number 3 is a natural log with e to the 5th. What's that invisible base there? It's an e. So what this does is it cancels, and we're going to be left with 5. So ln of e to the 5th cancels itself out, and we're left with our exponent of 5. Once again, we have a cancellation property here. We have log base 13 with 13 squared. Since these match, these two numbers, our answer is 2. All right, I hope you can figure those out. Again, once you have any questions, please feel free to contact me. I am here for you. Okay. Now gets into the fun part. I enjoy this part. So what we're going to do now is we're going to condense and expand. Our first two are condenses. So what we're going to do is we're going to write multiple logarithms as a single logarithm. To do that, we have to use our properties. Okay? So using our properties, we have a 4 out in front. That means this is an exponent of 4. So this means this is log 2x to the 4th. Sweet. Well, we also have plus log 2 to the y. Okay. Our bases are the same, and there's an addition. This means this is product rule. So I can take the 2 logarithms, and I'm going to make it into 1 logarithm. So I'm going to keep log base 2. But because of that plus sign, it says I'm now going to take my x to the 4th, and I'm going to multiply it by y. So my answer here is log base 2 of x to the 4th times y. If you don't want to have that there, it is still the same thing as writing it like this. So when we write as a single logarithm, we're going to take multiple logarithms of the same bases, reverse it into properties, and allows us to get to 1 log that should have been the original log in the same base. If you feel really confident, please go ahead and continue by yourself. If not, please follow along. This one's interesting. I have a minus and an addition. Okay, let's go through it. Our first thing is we have a number. We need to put it as an exponent. We have another number. Put it as an exponent. So I have log with an invisible base of 10, so we don't have to worry about it. Log with base 10, 5 to the third, minus log of y plus log of z squared. So we've done our product rule, not our rule. Power rule, wrong P, sorry. So power rule, a lot of people forget power rule. Make sure to do power rule. Well, our next step, we have done our power rule. We have a minus and an addition, minus and a plus sign. So minus means division. So that means these two are going to become log 5 to the third divided by y. We still have this plus. If you understand what's going on, do you have to write all my steps? No, you don't. But just in case, here they are. So we know division happened. A plus means multiplication. So this means I'm going to take log 5 to the third times z squared all over y. If you want to take and multiply it by 5 to the third over y, it's the same thing. I have a 5 to the third though. You should all know what 5 to the third is. You have a calculator. Please simplify your numbers, okay? Simplify numbers and variables if they are available to you. So we're going to take 5 to the third and say this is log 125 z squared all over y. And we have condensed our logarithms into one log. This is how condensing works. Take a bunch of logs, you do your power rule, then you do product or quotient based off of a subtraction or addition. So condensing, one log, that's the big thing. All right, our last two problems, and then you're done for week 1, is we're now going to expand them. So we took a bunch of logs and we were like, 1. Now we're going to take 1 and we're going to make them into a bunch of logs. Make sure everything is by itself. That's a huge deal. So right here we have log base 3 of 2a to the third divided by b to the fifth. So what this says is I have log 3 2a to the third divided by b to the fifth. So division means subtraction. So I'm going to say 2a to the third minus log 3b to the fifth. Sweet. Well, this says log 3 2 times a to the third. Numbers have to be by themselves. So this again expands to log 3 2 plus log 3a cubed minus log 3b to the fifth. I now have every single element by itself. Now that I have every single element by itself, I look at power to a power rule. This one doesn't have a power, so I can leave it alone. So this remains log 3 2 plus 3 is going to go out in front. We have 3 log of 3a minus, bring out that 5 log of 3 to the b. So this means I have expanded my logarithm into as many logs as that was as its condension. So we went from 1 to 3. So that does happen. Make sure every element has its own log. Yes, it gets long and tedious, but we're working both backwards and forwards. Make sure to do that. If you feel confident, try number 8. 8 has a trick. So make sure you pay attention, but try and do it on your own. So we have natural log with an invisible base e. Do we have to write e every time? No, we do not. But I have 1, 2, 3 elements. How many natural logs am I going to have? I'm going to have 3. So that means I'm going to have ln of 8 plus ln of x squared plus ln of the square root of y. That one's new. That might be our trick. Well, ln of 8. I don't have to do anything with that. That's nice. so I can rewrite it. ln of x squared. Ah, there's an exponent. So I can put it in front. So we get 2 ln of x. This last one, can I do anything to it? The answer is yes. We have to remember that the square root of any number is the same thing as an exponent of a half. That also means if you have a cubed root of any number, it's exponent of 1/3. The index is 1 over your index. You must remember your exponential rules. So what this says is the square root of y is the same thing as y to the 1/2. So that 1/2 has to come in front because it's an exponent. So we're adding 1/2 ln of y. All right, that was a really long lesson today, but if you have any questions, that we do have our Zoom meetings on Monday, and I am available at any time given of emails. Please email me.